Okay, if you are watching this, this is our finishing of notes for section 1.9, which is inverse functions, and we're finding inverses algebraically. And I did want to go over a couple of examples where we find inverses algebraically. So just a reminder that this is the equation of a line, and so since it's linear and it's not vertical or horizontal, it does have an inverse. So the first thing I usually do is go y equals 5 minus 3x over 2. And then a lot of times I just draw a little line or something. And for the inverse, we're going to interchange x and y. So x equals 5 minus 3y over 2. And then we're going to get y alone. And so the first thing we should do is multiply by 2. So, and I'm just going to go up over here so it's a little higher. And we get 2x equals 5 minus 3y. Personally, I might add 3y to both sides, and then that's 2x plus 3y equals 5. Then subtract 2x. 3y is 5 minus 2x. Divide by 3. Y is 5 minus 2x divided by 3. We already had a moment where people kind of did this. So if you got a negative 3 here and then 2x minus 5, am I right? You would want to maybe multiply both the top and the bottom by negative 1. Negative 1 over negative 1 is still equal to 1. It didn't change the value. So f inverse of x is 5 minus 2x over 3. And notice kind of the relationship to f of x and f inverse of x, just as you look at those. And then the weird thing about these slides is that was our function, correct? And we said it's linear. If you look at the next slide, it shows a graph, but do you see that it's not the same graph? It's not the same function at all. So I don't know, that's just a little weird thing about that particular problem. And they maybe did a different problem, but that's okay because we have a problem like that right here. So this is our next one, 5 minus 3x and over x plus 2. And if you kind of think about that, that is going to be one of those kind of an inverse function. You just kind of maybe solve that little thing. So it will have an inverse. It's a, excuse me, I said inverse for function. It's a reciprocal function is the parent, and so it will have an inverse. It's kind of that graph that has those kind of two C-like looking things in it. So this one is y equals 5 minus 3x over x plus 2. To find the inverse for this one, we interchange y and x. So x equals 5 minus 3y over y plus 2. Do you agree that's going to be a little more involved, right? And so we're going to multiply by y plus 2 to get rid of the fraction. And on this right side, they just cancel out. I'm going to distribute there, and I'm going to get xy plus 2x equals 5 minus 3y. Do you agree with me when I say we have to get our y's on the left and everything else on the right? And so there will be x's and y's on the left, and just non-y's on the right. So we're going to do two things. I'm going to add 3y to both sides, and at the same time, I'm going to subtract 2x. And so I'm going to get 3y plus xy equals 5 minus 2x. Just give me a head nod if I did that right. Okay, and because sometimes I don't. And our job is to get y alone again. And so what is true about that left side? What can I do with the y? I can take out the y, and so distribute that out. And I, again, will go up to here. So that'll be y times 3 plus x, when I distribute that out, equals 5 minus 2x. And then I want to get y alone, so now I'm going to divide by 3 plus x, or x plus 3. It doesn't really matter. 3 plus x. And then those will cancel. I'll get y equals 5 minus 2x over 3 plus x, or x plus 3. Either way is fine. And then this is f inverse of x equals 5 minus 2x over 3 plus x. Do you agree? The next one I just wanted to go over, and there's that one, is one that has a square root function. And of course, we have a restricted domain, and our range is all positive values. Do you agree? Because when we take the square root, if we're going to get a real answer, it's going to be a positive. And so we start with positive things, and then if we have to restrict that further, when we find that inverse, then we can look into that. And the domain of the original is restricted to 2x minus 3 being greater than or equal to 0. But we're going to not handle that part of it right now. Oops, minus 3. And so then for the inverse function, we'll say x equals the square root of 2y minus 3. What am I going to do to that to get y alone? I'm going to square both sides. I'll use a separate color just to kind of illustrate that a little easier. So x squared equals 2y minus 3. To get y alone, we'll add 3, so x squared plus 3 is 2y. We'll divide by 2, x squared plus 3, divided by 2 is y. So this one gives me f inverse of x equals x squared plus 3 over 2. Whoops, for that one. And hopefully you're kind of seeing the relationship. This one's kind of pretty easy to follow, that, instead of square rooting 2 times x minus 3, we square x, add 3, and divide by 2. Then in our last one here, it's just a cube root problem. And so this is y equals the cube root of 10 plus x. By the way, what's the domain of this original function? What's the domain of the original function? All real numbers. Why is it all real numbers? It's the cube root. It's all real numbers for the domain because it's the cube root, and so that index is odd. So, if we didn't manipulate it at all, the parent function looks like that. I'm not graphing all of these. We had a whole section on graphing, but it's that kind of idea. So is this one-to-one? Is it one-to-one? So if it's one-to-one, that means it passes the vertical line test and the horizontal line test. Since it's that kind of shape of an S, we know that its domain is all real numbers and it's a function, and then its range is also all real numbers and it's a function, and it's one-to-one. The horizontal line only passes there one time. So then for this one, x equals the cube root of 10 plus y. And what are we going to do in this one? Cube both sides. We're going to cube both sides, and then we get x cubed equals 10 plus y, and then to get y alone, we'll subtract 10. X cubed minus 10 equals y, and so then just writing it in function notation, f inverse of x equals x cubed minus 10. So can you algebraically come up with a function? Or an inverse of a function. Yes. Okay, so just a reminder, let's see, tomorrow is your review day, and some of you have a huge amount of work to do, I would say. And so I will have keys available to you if you want things highlighted and to check over some of your work. Just keep in mind that I will be, when I grade your homework, or when I look at your homework, I think something like this rubric is on the assignment sheet, but I will give those of you who are in the room today the kind of homework rubric, just so that you're aware of that.